All right, today we're talking about solving absolute value inequalities. So I'm going to kind of jump around a little bit from the assigned work because it is a lot of self-discovery and stuff like that, but it's tough to do when you're on your own. Kind of reviewing, it says on 9-25 from chapter 3, okay, if you're given an if you're given an absolute value, if you recall, you're supposed to write two different absolute value equations where we say 3x minus 5 equals 16 and then 3x minus 5 equals negative 16. So we have two different equations now. Add 5 to both sides, so we get 3x equals 21 and we get 3x equals negative 11. Divide by 3, divide by 3. So we get x equals 7 and x equals negative 11 thirds. We get two different answers. Okay, so it's going to be very similar when we're solving absolute value inequalities. However, this part is where we get confused in writing two different inequalities. So now if I just jump down, I'm going to skip 26 and 27. And 20, let's see, we'll go to 30 because that's kind of where it starts to get at. Everything else is just kind of self-discovery stuff. So you could kind of go through that stuff if you'd like, but essentially I want to just take a look at some examples. So we have absolute value of x minus 2 is less than 3. So whenever we are solving absolute value inequalities, okay, our first step is to get the inequality on a side by, or get the absolute value on a side by itself. Okay, in this example, they've already done that. Okay, absolute value is on the side by itself. If there is a number out in front, if there's a plus 2 or whatever, we'd want to move that to the other side. But in this simple example, okay, it's already on a side by itself. So step 2, you're going to write your two inequalities now. Okay, so this is the important step. Okay, it's where a lot of people, where you can make a lot of mistakes. What you want to do is write your two different inequalities. So we're going to change this. We're going to leave that first one the same. X minus 2 is less than 3. On the other side, we're going to write x minus 2. We're going to flip the sign and make it negative. So flip sign, change to a negative. Okay, so a lot of times people will either forget to flip the sign, forget to make it negative. Either way, it could cause a lot of problems. So now we have our two inequalities. We just want to solve both of them. Add 2 to both sides. We get x is less than 5 and x is greater than negative 1. So on a number line, okay, x is less than 5, it's going to be an open circle, it's going to the left. Over here, it's greater than. So we end up getting a number line that looks like this, basically stating any number between negative 1 and positive 5 is going to be in a solution. So you can always test it out. Okay, easiest number in this example would be to test out 0. That is the word test, so we're going to test 0. Plug it in, we get the absolute value of 0 minus 2, which is the absolute value of negative 2, which is just a positive 2. 2 is less than 3. which is what you're looking for. So you end up getting a true statement, which means 0 should fall in that shaded region right there. Okay, you could test the number outside of the region and make sure it doesn't work, such as -2 or 6. Okay, you could plug those numbers in, check, make sure it doesn't work, and that way you kind of know that you have the correct shaded region. So I'll go through 31, A, B, C, and D. Feel free to, if you're watching this on a recording, you could pause it and try them on your own, okay, and then check your work. That'd be a good idea. So 931, A, pretty straightforward. Absolute value of x plus 2 is greater than 1. Absolute value is on the side by itself. So now I'm going to write my two inequalities. X plus 2 is greater than 1, and x plus 2 is now less than a -1. So I get x is greater than -1, x is less than -3. Okay, greater than -1 is going to go to the right. Less than -3 is going to go to the left. Okay, so we actually get an inequality or a number line that looks like this, where any number greater than -1 is going to work, and any number greater than -3 is going to work. So we were talking about whole numbers. The only thing that's not going to work for this is -3, -2, and -1. Okay, which makes sense because we have an absolute value here. So it's always going to be positive, and we want it to be greater than +1. It's going to be a lot of numbers because 1 is such a small number. B is awkward, but let's take a look at it. Absolute value of 2 times x minus 1 is greater than or equal to 0. Alright, so this is awkward because the absolute value is over everything, and so it's always going to be positive. If you take a look at the inside right here, excuse me, take a look at the inside, we want a number that's going to be greater than or equal to 0. If we are dealing with absolute values, it's always going to be positive. Okay, since it's always going to be positive, no matter what number you plug in here for x, when you take the absolute value, it's going to turn it into a positive. So a positive is always going to be greater than or equal to 0. So in reality, you can plug in whatever you want. Even if you take away the absolute value, it doesn't really matter. Okay, we can plug in whatever number we want for x. Okay, subtract 1, multiply by 2. At the end of the day, you're going to take the absolute value of it, and it's going to stay positive. So the solution for this one is all real numbers. I don't really like the way they did that. What they usually do, and what you'll see on test moving forward, okay, you'll get something that looks more like this. Okay, I don't know why they put the absolute value on the outside like that. Okay, just kind of ignore that. Take a look at this. It's always going to be positive, okay, because of the absolute value. Okay, plug in whatever you want, -1,000,000. Okay, you're going to get a really big negative number, but then at the end of the day, you're finding the absolute value of it, which is always going to be positive. And since we're talking about greater than or equal to 0, doesn't matter what it is, it's always going to be that. So you can plug in whatever you want for x. It's going to give you a positive number on the left-hand side here. Positive number is always going to be greater than or equal to 0. So you get all real solutions. And you'll see something similar on D here in a second. As I lost my, there we go. C, no absolute values. Even though that's what this lesson is on. Why did they give you one without absolute values? I have no idea. 9x minus 4 less than or equal to 6 minus x. Okay, so this is just like one we would have done on the first two lessons here. Get the x over here, move the 4 over there. So we get 10x is greater than or equal to 10. Divide by 10. X is less than or equal to 1. Close dot. Numbers that are less than x are over there on the number line. So we should be fine there. Again, plug in test points if you want. Plug in 0, it's always going to be the easiest one to test. You can plug in 0. Make sure it works. And if it doesn't, you can kind of go back and check your work. D on 31 here is a good one because this is more realistic of the ones you'll see. So we get 3x minus 11 is less than negative 2. Okay, so again, absolute value is always going to be positive. Always going to be positive no matter what. So now we're trying to find a positive number that's going to be less than negative 2. Not going to be able to do that. So these types of problems are no solutions. Okay, there's no number you can plug in for x. Okay, that's going to be less than a negative 2 because it's always going to be positive. Okay, so you'll see those a lot. If you flip the sign, it would be all real numbers because it's always going to be bigger than negative 2. But since you want to find a number less than negative 2, you're not going to find it because it's always going to be positive. So looking at the homework, 33, you're just solving equations with absolute values, pretty straightforward. 34, determine if it's true or not. 35, review solving systems. We can take a look at 36. It's a good one, just dealing with exponential functions. So 936 from the homework. Goes to the points 2, 3, and 5, 1/9. Okay, so we have our y equals a times b to the x for exponential functions. Write our two equations, plug in 2 and 3 for x and y. So 3 equals a times b squared, and 1/9 equals a times b to the 5th. Solving for a one of the variables, easier to solve for this one, we just move b squared over. So we get a is equal to 3 divided by b squared. I'm going to plug that in for that a. So 1/9 equals 3 divided by b squared times b to the 5th. Simplify our exponents. B to the 5th and b squared becomes b cubed. And now we're dividing by 3 on both sides. 1/9 divided by 3 is actually 1/27. So now we get b cubed over there. So this is a little tricky because it's got to be a fraction. Because we're trying to cube something to get 1/27th. Easiest way, we could just kind of flip it and make this a negative 3 and then flip the 27. So we actually get 27 equals b to the negative 3. Okay, or 1 over b cubed. So now you're just trying to figure out what cubed really is 27, which in this case is going to be, just running out of room. Go back to our original. Right there. B is just going to be 1/3. Okay, because 1/3 cubed. Cube the 1, cube the 3, you get 1 cubed over 3 cubed, which would be the 1/27th. Plug that back in. I'll plug it into the top one. So 3 equals a times 1/3 squared. So I get a times 1/9 equals 3. Multiply both sides by 9. A equals 27. Y equals 27 times 1/3 to the x. Super fun. The rest of the homework, plotting points. 37 is a good one because that was from last chapter as well, and I believe it's what the essential skill test is on next week or the week after that. Okay, but 37. Says the increased demand for vegetarian meals has caused an increase of the price of tofu. Cost of tofu is currently $2.99, increasing 6% per year. What will it cost in 5 years? So your initial value is $2.99. It's increasing by 6%. So we write 1.06. Okay, remember 1 plus our percentage is 0.06. So 1.06 raised to the 5th power. I have my lovely calculator. 1.05, 1.06 raised to the 5th. $4. 4.00129. Okay, so nice and even to $4. All right. So that's kind of where I'll stop today. If you have questions, you can email me. Let me know what's going on. I will add the assignment for 9.1.3's homework, so you can submit it on Schoology if you'd like credit for that. Some people are already taking a triangle congruency essay, so when you submit those, I'll grade them. And I believe the next one is going to be May 8th, which I believe is 2 weeks from today. Maybe it's 1 week. I'll double check the calendar on Schoology. Let me know if you have any questions.